Good evening, everybody, and welcome to another episode of vBrownBag. This evening, we are going into space. We are going to have some fun. We're going to learn all about how to use Python and JavaScript to build 3D tools in space. This is going to be a very fun conversation. I've been chatting with Christi about this for quite some time now, and I'm a fan of Python and space and printing, and let's be honest, I'm actually kind of a fan of Christie's too. So let's get on with this. But before we do that, let's do a couple of show notes. If you want to get in on the conversation, if you at vBrownBag or hashtag vBrownBag, I will be paying attention on Twitter for the however long Twitter is still going to be a thing. We'll see. I might be listening on Mastodon pretty soon. But we are paying attention both in the Q&A. So if you are in the live studio audience, we will be answering your questions there. And if you hashtag or at vBrownBag online, then I will field those questions as appropriate to Ms. Kazakov. If you want to follow her on Twitter, you can find her at Christi_Kazakov on there. She just created the account, so give her a follow. She should be super famous any second now.
Any day now.
And I discourage anybody from following me. It's just cat pictures and IT stuff. So, Christi, how are you doing this evening?
You know, pumped, excited, nervous, anxious, all the good feels.
After a shot and a beer, how could you possibly be nervous?
You know, good question. It is what it is.
So you and I met when we were working together on a tiny little streaming company for the company that we both work for, and you started talking to me about this cool little side gig that you were doing, and I was like, oh, that sounds like a vBrownBag conversation, and so you've graciously decided to do this with us.
Yeah, after months of asking and me reluctantly finally saying yes, here I am.
After haranguing you and you giving me excuses like, oh, I'm partying in New Orleans right now, I simply can't. Or no, I'm Sailor Moon on Halloween, I simply can't do this.
It had to be done.
All right. So how do you want to do this? Do you want me to turn the power over to you? Shall I?
Absolutely.
Shall I relinquish and you?
I can.
There you
I
go.
can take the power.
You
Can
got
you
it.
see everything?
I
Nice.
can see everything.
Hopefully, just the pretty PowerPoint that
Yep.
will one day not exist.
Well, technically, it's not a PowerPoint. It's a Google slidey.
It's a Google thing.
I forget.
Google's so cool.
Google Slides. Is that what they call it?
Yeah, Google's so cool. We're
There you
still in with Google. So Python and Java with aerospace. So, little background on me. My name is Christi Kazakov. As we've just determined, I'm a senior software engineer based out of Denver. And I have worked on a lot of really cool projects over my career, not just at our current company, but even the last one I worked at. Some of it was geospatial. So I worked on the Colorado Parks and Wildlife fishing app, which used citizen science to use that data to better implement processes within the government around the fishing and wildlife, and use actual map data, very fun stuff. I also worked on a app that it was essentially an app where you could create, manage, and publish all of your Google and Alexa skills. Hopefully I do not summon her right now in the back.
Whatever you do, don't say Alexa out loud. Oh no, I said Alexa out loud.
Right? And that was really cool because we were also able to add like databases so people could make really dynamic skills before that was a thing. So that was like one of the really fun projects that we worked on. At the current company, I've worked on some pretty big and very innovative projects, one being a telecommunications company where we auto-magically hooked up hardware and software and we're able to run different test scripts against it, such as like testing your Wi-Fi against your modem and your router, and seeing like how your voice works against, like, if it has voice capabilities, like being able to test that. So super fun stuff like that. As you mentioned, we worked on like a massively small streaming service together.
Only the second largest radio streaming service on the planet.
If you're not first, you're last. So, you know.
Nice, Ricky Bobby. Good job. Shake and bake.
Yes. And then another really fun one was a data science project I worked on, which was a mine forecasting with big data. So we took existing Excel data and Visual Basic functions and converted it to Python. The guy who did the audit said it would take like hours just to change numbers in order to generate and rerun all of the calculations. And the calculations themselves took like 2 days, single precision, very error prone. And we got it to run with Python in under 30 minutes, double precision with, and I think we reduced or like improved accuracy up to 30%. So that was really awesome.
Nice. That sounds like yet another vBrownBag talk, if I'm going to be fair. Actually, I should introduce you to Mike Kennedy. He would love to do that talk with you.
I love meeting people.
Okay.
Pick it up. A win is a win.
I'm going to make this happen. It's done. It's done. All right.
Perfect. So moving into, because I don't have enough to do during my workday, I decided to take on a project outside of work. So
you're crazy.
I know, I'm insane. I'm constantly bored, so this is what I do. My very good, like best guy friend, Michael Botirov, we met in college actually. So he's an aerospace engineer and he's going for his PhD and approached me with this project. And I was like, ooh, all the things I want to do. I like it. Let's do it. And so this is really based on aerospace engineering and trying to like test his thesis for his program. And this is around generative design, which I will say the quotes. It's from Newton Corp, but generative design is an exploration catalyst. It helps engineers evaluate more possibilities in less time to achieve optimal outcomes faster with better insights and desired performance. It's a collaborative approach that augments engineers' capabilities and creativity with computational force. So lots going on there.
I have several questions.
Lots going on, yeah.
Oh, what did that mean?
What in the front?
Excuse me.
So this kind of deals with additive manufacturing, which I can also define, and it'll sound very familiar to you, which is computer-aided designs to direct hardware, which deposits material layer by layer in precise shapes, which is, if you guessed it, 3D printing.
I was going to say, that sounds like 3D printing.
Yes. So generative design essentially is this system where you continue to iterate over the process to make better designs for whatever the problem is with 3D modeling, and then being able to actually print that. So super cool stuff.
Okay, all right.
Cool. It's real hip. So
when are we going to space?
Right? Before we go to space, real world scenario. You're in a car. You're driving fast, you're late, something's distracting you in the back, your gas light just turned on, you're paying attention to the people on the sides of you. Lots of distractions. There's a lot of cognitive load that's going on, and you're needing to make quick decisions that are going to be efficient to get you to where you're going in the fastest, safest way possible.
Okay, I follow.
Yeah, so switching to space, you just got promoted. You are now an aerospace engineer, and you are in space.
All right.
Wild stuff. Yes. But something breaks, and they can't send another spaceship up to help you. Like, that's too much government money. Like, nobody has time for that.
Lives are cheap in space.
Exactly. No one really matters. Down Earth, space, different gravities, it's a thing. So you have only so many materials on hand. You have your 3D printer. So you get to generating models. And all of a sudden you're like, hey, I have all these cool materials based on these specs, whether it's, metal or plastic, or it's based on its volume or its mass, and you're trying to find the best tool for that particular problem that you're fixing. But you also, as an engineer, need to think about, like, if there's another problem, what is going to be the best tool to solve both problems at the same time? So there's distractions happening. There's something's already happening. Something else might be hitting that pressure point where it's about to break. So you need to think of a solution fast. So this app essentially is testing an engineer's cognitive abilities under stress to find the best model in order to fix the problem at hand as fast as possible.
Okay, so let me get this straight. I'm a guy in space, or girl in space. I've got a 3D printer, and something bad has happened. I've got stress happening at me, and I need to use this 3D printer to create something that's going to fix the stressor or the problem or the thing. And so we need to figure out, we need to create a test to decide how good I am at creating that tool under pressure, under cognitive load, to fix the problem of air escaping from the capsule or something like that.
Perfect. Bingo. You got it. We're really testing your abilities here as an engineer in space.
Okay. Sounds good. All right. So that's the task. What was the issue, and how to, and I'm sorry, I'll shut up. I have so many questions, but I'm sure that you have a process that you're going through here.
I have the full process.
Okay. All right. This is Chris shutting up now.
This thesis essentially is about pushing the space for on-demand tool model generation in high-stress environments, which is going to become more and more prevalent as time continues and we keep growing in that space and realm.
As more air leaks out of the capsule.
Exactly. Staying alive. There's a song about it. We all know it. Don't make me sing it.
I think you should.
No. No. Let's not do that. So for the process, this is the generative design process. So what this is essentially saying is you generate various models, you evaluate those models, you regenerate based on specific specifications and different criteria that you need and make it better. This cycle continues until you are ready to start printing. So this resembles the app process as well, actually. So a user will sign in with some token. That token essentially just allows the person's data to be sorted, all of their images and the metadata around those images to be sorted by that token. And that can be from mass to volume to material to no filter at all. And
the criteria for the tool that needs to be made and why it needs to be made, like the metal or plastic or whatever like that.
Yeah, exactly.
And how much material you have on hand.
Yeah. So, and then there's going to be for so each time a user goes through this test, they go through 7 different iterations with that token. The first one starts with 1,000 images, and then it gets smaller. So you're getting a smaller subset of the first subset or the first set.
Okay.
And that's getting more and more efficient as you go down all the way until you only have 10 images. So this is the first task, is based on some specifications, choose the best tool out of 1,000 images or 10 or whatever you have in between.
Okay.
There's also a secondary task, which is a comparative, which essentially just asks the user, hey, choose the one that's the most different out of all of the 4. And that is going to be different based on the filter that's used, that token, and what iteration it's on as well. Following so far?
I believe that I am. Yes, I have more questions, but I'm also going to, table them. I want to make sure that you get your words out, and then I can follow up.
Perfect. Okay. And then so after each task, there's also this thing called the NASA TLX survey, which is where the cognitive survey comes in to see how the user felt during each test. So I'm going to be able to show that. As a developer for this project and learning, I ran into a couple problems, which were really fun Googling and trying to solve as well. So on a bigger note for me, one of the biggest things was being able to load 1,000 images and sort them accordingly very quickly, so it's not taking forever, making sure it's efficient, looking at how to implement a ORM, which is an object relational mapper. So that essentially is what ties to your database. So you're not using your database directly for security purposes, and making migrations easier if you need to make changes to your underlying schema. So that was fun to learn with Python because I haven't really done that before. I set up a React app all from start to finish, which I've not usually done. I've kind of gotten into pieces or came in after it was already set up. And then deploying this to a new system that I've never used, which was Heroku. And that was really fun to learn. Had to get a little help from people who had a little bit more experience at times, but
yeah,
we all need help. So I'll pause there before we demo. Did you have questions, or did you want to wait until after the demo?
So the generative design. So the decision making process. Okay, so I'm trying to like pattern this into like I'm the person in the spaceship, and I'm selecting I'm the guy on the ground playing the game. I'm going to call it the game. Playing the game where they're trying to figure out how to select the tool that's going to help to prevent the air from escaping from the spaceship.
Right.
And their selective criteria process is similar to the actual process that you went through to create the game itself. I'm saying game, but it's not a game. What are you calling it?
I mean, I think that's accurate. I just call it the process. I don't know what else to call it.
I think of it. I mean, it's this whole life, game of life. All life is a game.
Test. It's a test. It's a real test, you know. But yeah, it absolutely was, which I didn't think about until much later. And this is a process that is used in the real world. So this is something that aerospace engineers do in their jobs when they're generating these models. They will go through, select some set, and then create a new subset to refine that more as they continue forward until they can find the best out of 10 instead of like hundreds of thousands or thousands.
So is your program currently being used at this aerospace place or at NASA, or where's it?
Oh gosh, I wish. No, not yet.
This is being used by your PhD friend.
Yes, so this
Gotcha.
is going to be out in the wild here shortly because I am in that last 10% that takes 90% of the time. I'm in it, so we're hopefully going to get them out and testing it with actual students in the aerospace space.
The aerospace space.
Space squared.
Cool.
So.
This is very cool.
Yeah, it was really cool learning about it. A lot kind of got over my head, so it was really cool to dive into it and see some of the models and some of the programs that they use as well. So it takes forever to create if you have a crappy computer. So mine do that.
But it works lickety split on their computers.
Exactly.
Awesome.
Okay. Are we ready for the demo?
I don't know. Have we sacrificed the appropriate chickens to the demo gods? This is the.
We might.
Is this a live demo?
This will be a live demo.
Holy Coley.
Let's hope. Don't judge me for like who.
What? What?
Oh no!
So much judging. As an ex-Patriots fan. No, I'm kidding.
I know. I'm sorry. We were both fans. It had to happen. So this is the first page that kind of just gives you a little bit about what the generative design study is.
Okay.
Little outlook, some general info. They use this program called the Autodesk Fusion 360 to do the generation of all of those images. So you're going to see that in a moment.
Okay.
So this is going to be the first iteration. So it's loading in 1,000 images. It's sorting them appropriately. There's some kinds of specs here listed. And there's a little distraction, the real world distraction, as you would think. So something's like beeping at you while you're trying to figure this out. So here's the click me to.
What's the real? Oh, the click me is the real world distraction.
Correct. So as a developer and for the project itself, we're timing and randomly putting up that button, and then we're recording how long it takes for the person to click the button, but also select an image based on those specs there on the right. So this will keep popping up randomly until they have selected something.
And do they have to keep clicking it until they can't select it, or they can just ignore it?
They can ignore it, but that will also be recorded. So
how does that simulate air escaping the spaceship?
It's supposed to simulate something like beeping at you or like some kind of alarm going off. Thanks, Chris.
They should hire a live monkey to come jump on his back and just beat him on the head.
Did my best here. Thank you. So going through, so this first iteration has 1,000 images. As you can see, like the scroll bar is like really, really small. So there's a lot to go through.
Holy
and you're like, I don't know what to look for. And you're like looking at this and you're like stuff between 0 and 9.2. So you're having to evaluate things based on information, the metadata of those things as well. So
oh, I see. Okay, and you gotta click the stupid button while you're going through this.
Yes. So hopefully you're feeling stressed.
I am. This Iconal 1718. How would you even pick something from this mass array of shenanigans?
Right. I know there's so many choices. We can struggle with 2 or 3, let alone 1,000. So if we select one, it will then go to our NASA TLX survey, which then tests the actual cognitive load. So it asks the user, I will go through it really quickly because I don't want to bore you to death, but it just talks about where were you for the responses? Were you happy with the models generated or not so much? I'll just say I was neutral about everything. This first one, the mental demand was high, struggled there, couldn't read half the numbers. That was a lot of information.
I was sweating with that monkey on my back, absolutely.
Physical demand, I don't know. The scrolling was getting to me. I'll give it a 5. You know.
I have carpal tunnel.
It was a lot. Effort, that was a high effort for me to scroll through and try and read all that. Plus the distractions, no thank you. And then frustration, super high, really frustrated. That's
crazy frustrated, absolutely.
So next is the comparison task. So you're supposed to choose what looks the most different. And they all look different to me. So, we're just going to go with one.
Visually different. Top left.
Top left?
Yeah.
Great. We'll select it. Then you go through this again. There's no distractions on that last one. It's only on the first task, but we still want to check that cognitive drive and see where you're at. So I'll just do 50 across the board. And I probably won't go through every iteration because it's more or less the same, and that's going to get really boring really fast. So
so that was iteration 1. So there's 7 of those.
Correct. So they will all get filtered. I will go to the next one. So now it's going to be different specs. Last time it was 9.255 or something like that for this first one. Now there's a whole lot less images. As you can see, it's a little faster to scroll through. So This is going to go until you get all the way down to only 10 images on the screen. And then it signs you out, and then you can essentially start the next set under a different token. So you get different filters as well as you go through each iteration to test that load.
What are Max von Mrs. stress?
You're asking me things I don't actually know the answer to.
Look, I just made the game, Chris. Shut up. Okay.
Yeah, I think essentially, so all these deal with the material. So the pressure points for that material, the mass, volume, what it's made out of. I don't know about the manufacturing method at all. I think that could play into some of the 3D printing bits, but I don't entirely know. So yeah, these all kind of change based on the iteration, and then the images will change based on the sorting of the token. So that's my live demo.
And it worked.
It worked.
Oh,
First time.
and that's the repo for your game.
That is the repo, but then you can see all my other sad projects.
Okay, so once they've gone through your game, I keep calling it a game. It's a video game. It's Pong.
It's a game.
Once they've gone through it, what do they do? Are they evaluated as no, you're too dumb to go to space because you can't figure out, in the proper amount of time, or what happens when they pass and what happens when they fail?
Yeah, so I don't know that there's actually a pass fail in this scenario. What they're doing is collecting data and then doing an analysis on how to better generate better models for whatever task is at hand, whatever specs that they choose. So they're trying to continue implementing that performance and optimizing that, but also they're trying to minimize that cognitive load and that stress level as you're doing this, so that they can train up better for the models and problems as you move forward.
So instead of hiring smarter astronauts, they're just giving them easier tool selection processes.
Absolutely.
Okay.
Absolutely.
I was stressed out by that, so I'm sure that a real astronaut would be just as stressed.
Yeah, absolutely. So yeah, they're trying to improve those processes, and really the point of the project itself is to test that load, that stress bearing based on that, because that is a real world type of scenario where you're loading in 1,000 images, trying to select the best one. How do we improve that process? How do we make it easier for aerospace engineers to create these models and tools under high stress scenarios?
Okay, so I am gonna put the links in the show notes and dive into your repo. What kind from a programmatic perspective, what kind of challenges did you run into? What kinds of things did you what were some of the things? So like if somebody was looking at your code, what would they run into, and what kinds of things were like, oh, that's really cool?
I'm so glad you asked, Chris. First thing is I didn't write tests, which is a big no-no. So they're going to be definitely disappointed with that one.
No test writing. I have an entire episode on why you're supposed to write your tests before you even write it. Never mind. Go ahead.
And Sorry. I'm the biggest test advocate, but I just went with it because I didn't take this seriously until I was already so far in.
and this was your side project, so it's not like you're having to be like super diligent about it.
Yeah. So some of the fun challenges, I kind of mentioned loading in 1,000 images in a relatively quick time is actually a massive challenge. So it took a bit of Googling and checking and trying different libraries for really researching what kind of image formats to use in order to load this in at a fast rate. And I tried to keep this very YAGNI, which is, I'm gonna blank on what that means right now.
YAGNI?
YAGNI.
YAGNI.
I'll Google it properly.
I'm not familiar with the term, but if it's...
Okay. Got it. So Martin Fowler, Uncle Martin, he's my favorite. So he is a big proponent of you aren't gonna need it. So if you're not gonna need it, don't implement it. It's one of those don't overdo it before you need to. So I tried to kind of stick to that a little bit, not implement things before I needed to. So I actually didn't start with the ORM until much later. And with the images, I just had a static set of images and would just pull them without any sorting. Then it was, how do I make this more performant? And so I had to split that up using Python comprehensive lists which is like 30% faster than just looping through like a normal for loop, for example. So just improving process like that and seeing how I could implement that. What kind of headers and like image compression I could do. So I was like really diving in. It took like a month of research and like trying to play around to like really get this down to be really as fast as I could get it with 1,000 images.
Wow.
Yeah.
Have you tried to run it or time it since Python 3.11 came out with all of the performance improvements?
No, I actually, one of my goals after this podcast is to do a lot of upgrades. So I didn't break things for this.
Your requirements.txt file is getting a little cobwebby.
Yes, I was going to say SQL Alchemy also is one of those things where I've worked with ORMs before on projects, but never with Python, or maybe like very minimally with Python and not with Postgres. So I incorporated that because I had already gotten the deployment process through. And after you get that through, you just need to run migrations. It's really hard or not advised to, make database changes to like an app that's been deployed. So I incorporated that kind of late. Problematic.
You should totally do that on the fly. What are you talking about?
Whatever.
Push to prod. Go ahead.
So yeah, that was like another challenge because I was like, this is a lot of stuff I haven't worked with that I had to kind of gain speed on kind of quickly for like a side project. And that was really cool. That kind of helped also with some of that performance, but I also need to upgrade the app because I'm using a right now deprecated version. So I need to get it up, which shouldn't be problematic, but again, got to be cautious. Don't just upgrade
I appreciate you
everything
not
else.
doing that before the demo. So
Correct.
now you can run that in your dev environment.
Exactly.
Cool. Okay. Is there a question that I'm too dumb to ask that you want me to ask that I just am failing miserably at because I'm not smart?
That was a smart question. I don't know.
So
Yeah,
what's the next step for this? Your PhD friend is implementing this in his doctorate program, and then they're going to implement it at NASA, or what's going to happen with it?
so I think he's going to use this, and he works for Sierra Nevada, so another really big like aerospace institution. Not the beer, just to make that very clear, because I got confused the first time.
See, I'm old school. I was going to say the video game company, but you probably don't even remember that.
Nope. This is so deep, we don't even know it. I think so. Yeah, once he gets the analysis and is able to like bring that down, crunch it, do whatever he needs to do, he can use that on his projects. And he's also he does a lot of stuff, so he's like insane. So he has that job. He also teaches and he does Ironmans like every couple months. Like he's insane. So
you're also insane. This is your side gig. You're not even getting paid for this. You have a day job.
He pays me with margaritas.
Does that count? Okay, all right.
It counts. So yeah, so next steps for me, besides doing some upgrades, is running a couple different migrations. Right now, I'm getting the token stuff finished because right now I like need to be able to create a new user that with whatever token and properly run through that. And right now I have static users, so I'm have like one or two final migrations for that, and hopefully this will be put out in the wild for him to begin testing for his program.
Nice.
Yeah.
Cool. And is it going to stay on Heroku, or are you going to package it up?
It's, I think, going to stay on Heroku for the time being, because they kind of have everything, and they're making some changes as well. So it's been fairly easy to use, and their CLI tool, their command line tool, is like pretty simple as well. So I think it's going to stay there for now. It's already hosted. You can add like a Postgres database for free. We're going to upgrade that as well here in the next week or so for the actual users, because we're pulling in all of the survey data as well as the image and distraction information as well. So there's going to be quite a bit of data if he's going to have 20 people running this with so many tokens.
Nice. Well, this was super cool. This was very interesting. I love the how you're able to break it down into the different areas, and I hope that it helps the engineers select things better, faster as air is leaking out of the spaceship.
Yes, improve the generative design process.
They're going to come back down from space and be like, "Thanks, Christi. You saved our lives."
I'm a space not now.
Cool. All right. Let me see if anybody in the audience has any questions.
Perfect.
Keep it simple, stupid. Can't phone a friend. Had chicken noodle soup tonight, if that counts.
So
nope.
helpful. Correct.
Does not sound like we have any questions in the audience.
Great.
Cool. Well, Christi, thank you very much for coming on. As always, it's a pleasure chatting with you.
Of course. I'll chat with you later.